Hello, my name is Kalidas Porika. I am the founder of Virtual Network Element. Virtual Network Element creates control plane network functions that are virtualized that can go on both containers and KVMs. We have a framework where we can automate the process of creating virtual network functions using our framework. In this application, we have a application that acts as a diameter routing agent or a diameter signaling controller or as a diameter edge agent that sits between push to talk server and the different PCRF segments. Application, the gateway, looks into incoming diameter packets and then routes them to appropriate PCRF segments. That it looks into the diameter's IPv6 prefix in the diameter packet before routing them to corresponding PCRF segments. It also has the ability to look for the subscriber information from HSS over SH interface and then do the routing dynamically. So let's take a simulation. In this application we can also simulate the application function behavior or a endpoint behavior with our dynamic simulation. In here I'm simulating a diameter message that goes to the RX gateway, and here I have a IPv6 prefix with the subscriber ID. So when I send the message, I get the response back. This message goes to the diameter routing agent. The DRA routes it to the appropriate PCRF and then sends the response back to the gateway, and then gateway forwards or translates that response back to the push to talk server. So let's do it for another segment, and when I do send, I get the response back. And then we can also visualize these events as a web sequence diagram. So initially I sent the message to PCRF B, and the next I sent the message to PCRF A with using different prefixes. We can also get the tabular view of the data, and we can see exact diameter envelope with all its attributes, the frame, header, and the payload, that is the ABPs that is there in the diameter packet. It helps in creating a real simulation of the application function, and we can test subscribers without putting the real traffic onto the DRA. It also tests the interoperability between different network vendors. With this, let me take to the stats. So here I have stats that correspond to the PCRF segments. Each PCRF segment handles something like 6.6 transactions per second. That is both AR and STR. A are the originations and STR are the terminations. And here we can see 20k transactions, 20, 40k transactions per thread. And on a CPU or an Intel server or a container that has 24 threads, this translates to close to 1 million transactions per second. We can see multiple different data from different days. It has various options, and this framework is built on our internal framework, which is a 3-tier architecture that has protocol encoder decoder. That means we have the ability to create encoding decoding for any diameter interface, not just the RX interface, and a middle layer that translates that does the action of routing the packet based on the command or the command code or the application of the packet. And at the bottom we have the persistent layer. Right side we have uh, a redfish client that has the over ang It is basically we created our own custom protocol called Nerd protocol, and we have a Nerd UI and a Nerd JSON API. With this architecture translates to a neat microservices, like the reusable microservices. We have a control, the gateway and the Redis as a distributed services that can go on multiple data centers, and we have a static services like the UI, the database Grafana, and the visualization component called Grafana, and the database Graphite. So the Nerd client basically gives you the ability to modify the application. So we have here the monitor subscribers, like we can create new IMSIs, or basically the MSISDNs to monitor, or we can have the PCRF segments, or the subscriber lookup functions, where we can add the more IPv6 prefixes with appropriate routing information in them. We can also do all these modifications using our JSON API, and its format is very similar to any REST applications. Initially we need to get the login. Basically you get the what is the a code, basically UUID, and using that UUID you can modify or create all other attributes. And here we have our metadata that supports a dictionary of diameter interfaces. It supports not only RX interface but all the interfaces that are defined in diameter, and the structure looks something like this. So using this metadata we generate auto encoders, decoders, and the rule sets that define the diameter packets. So with the help of this we can generate support for SH interface if it is needed in future. Thank you, and thanks for your time.